a graphical representation and relationship of E, I, pi, and phi. By Eric Lindert. How does one calculate pi? What is phi? And what does it look like? What exactly is E, and what does it look like? Square root of -1? Calculating pi. Archimedes came up with an approximation, using the method of exhaustion. First, he inscribed and circumscribed a circle with a hexagon. He was then able to calculate the exact circumferences and diameters of the hexagons and could therefore obtain a rough approximation of pi, by dividing the circumference by the diameter. Among other geometric properties, he determined that the area of a circle was pi r squared. This was, in effect, dividing a circle into 96 segments, summing the bases of the isosceles triangles formed, and then using the sum as the circumference. Perhaps the term exhaustion refers to the state of the experimenter. As the Greeks believed that all that numbers were rational, ratios of integers, 22/7 was used. Had the segments got smaller and smaller, the basis for integrals would have appeared long before Leibniz and Newton. 600 years after Archimedes, the Chinese mathematician Zhu Chongzhi used a similar method. To inscribe a regular polygon with 12,288 sides. This produced an approximation of pi as 355/113ths, which is correct to 6 decimal places. It was nearly 600 more years until a totally new method was devised that improved upon this approximation. An early formula for pi. All trigonometric functions will be expressed in radians rather than degrees. There are 2 pi radians in a circle. In radians, the tangent of pi divided by 4 equals 1. It follows that the inverse tangent of 1 should be 1/4 pi. The Gregory-Leibniz series for inverse tangent of 1 is as follows. The sum, from I equals 1 to infinity of -1 to the I plus 1 power, all divided by 2i minus 1 equals pi divided by 4. Multiplying this by 4 gives pi. Pi then equals 4 minus 4/3, plus 4/5, minus 4/7, plus 4/9, minus 4/11, plus 4/13, minus 4/15, plus 4/17, etc. Though there are series that converge more rapidly, anyone with a calculator can get the feel for this. What is E? E has been attributed to the great mathematician, Leonhard Euler. It is the basis for natural logarithms, meaning naturally occurring, in contrast to, for instance, log base 10, which is man-made. E is based on natural growth. Natural growth would be that which increases via time. For instance, rising from 1 to 2, 2 to 4, 4 to 8, etc. Growth, or decay, formulae are used daily to predict populations. As in people, predator-prey calculations, heating and cooling, as E has been plugged into Newton's law of cooling. Radiation, interest rates, and much, much more. Though there exist other ways to determine E, I find this to be quick. Because 0 factorial equals 1 where 2 factorial equals 2 times 1. 3 factorial equals 3 times 2 times 1. 4 factorial equals 4 times 3 times 2 times 1, etc. and 1 to any power equals 1. E equals the sum from n equals 0 to infinity of 1 to the nth power, divided by n factorial. As 1 to any power equals 1, and 0 factorial equals 1. Equates to 1 plus 1 plus 1/2 plus 1/6 plus 1/24 plus 120th plus 1 720th plus 1 over 5040, etc. to 2.71828182846, etc. Used everywhere, I is defined as the square root of -1. One can visualize I on the imaginary side of the number plane. From Euler's formula, here are the basics. E to the ix power equals cosine x plus I sin x. Cosine x equals 1/2 e to the ix power plus 1/2 e to the minus ix. Sin x equals 1/2 negative I to the ix power plus 1/2 1 e to the ix power. Or, as convention has it, removing the I from the numerator in the sine equation is done by multiplying numerator and denominator by I. Recall that I times I equals -1. What is phi? Ancient Greeks used a ratio for art, paintings, sculptures, architecture, music, etc. Consider a line divided into two parts, a larger and a smaller. The ratio of the larger to the smaller is the same as the ratio of the whole line to the large segment. This ratio is called the golden ratio, or commonly, phi. How to evaluate? X over x plus 1 equals 1 over x. Multiply both sides of the equation by x. Now, x plus 1 equals x squared. Thus, x squared minus x minus 1 equals 0. Quadratic equation, let a, b, and c be real numbers. The solutions of ax squared plus b times x plus c equals 0 are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Here, a equals 1, b equals -1, c equals -1. Substituting gives us x equals 1 plus or minus the square root of -1 squared plus 4, all divided by 2. As x is a positive number, we now have x equals 1 plus the square root of 1 plus 4, all divided by 2. Better, x equals the square root of 5 plus 1, all divided by 2. We get is approximately 1.618033988875 etc. Does x minus 1 equal 1 divided by x? Yes. Fibonacci determined a rabbit population basis where one female and successive daughters would bear 2 offspring. The Fibonacci sequence is seen in nature as a growth pattern. Classically, the sequence is simply starting at 1, adding the 1 to the previous, 0 gives 1. Now the sequence has begun. Adding 1 and 1 yields 2, 2 plus 1 equals 3, 3 plus 2 equals 5, 5 plus 3 equals 8, and so forth. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, etc. Interestingly, dividing each number by the previous number gives 1 divided by 1 equals 1, 2 divided by 1 equals 2, 3 divided by 2 equals 1.5, and so on up to 233 144ths equals 1.6180555, 377 233 equals 1.6180257 etc. Resulting in 1, 2, 1.5, 1.666, 1.6, 1.625, 1.615, 1.619, 1.6176, 1.6181, 1.6179, 1.6180555 to 1.6180575, and so forth. Look familiar? The number of petals in a flower is often one of the following numbers: 3, 5, 8, 13, 21, 34 or 55. For example, the lily has 3 petals. Buttercups have 5 of them. The chicory has 21 of them. The daisy has often 34 or 55 petals, etc. Furthermore, when one observes the heads of sunflowers, one notices 2 series of curves, one winding in one way and one in another, the number of spirals not being the same in each way. One might ask, why is the number of spirals in general either 21 and 34, either 34 and 55, either 55 and 89, or 89 and 144? And for pine cones, why do they have either 8 spirals from one side and 13 from the other, or either 5 spirals from one side and 8 from the other? Why is the number of diagonals of a pineapple also 8 in one direction and 13 in the other? Now you know, and it is quite natural. Oh, my God! Surely, you do not expect me to read all this then? The Maclaurin series, yes, very good then. Read along to yourselves, as I am on holiday. Ciao for now. Yes, here you have it then, all together, E, I, pi, and phi, in one equation. Good night, all.